Good morning, grade 10s. We are now going to look at trigonometry using a calculator to calculate the values. Given in 6.1 there, you are given that if x equals to 37 degrees and y equals to 44 degrees, calculate the value of sine squared of x plus 2 cos y. Let me just maximize here so that you can see the question. You see your 6.1. If x equals to 37 and y equals to 44 degrees, calculate the value of sine squared of x plus 2 cos y. Now, let us start to answer 6.1. 6.1. We want to find the value of sine squared x plus 2 cos y. Now, what it means now, let me take a different color. What it means, where you see x, replace with 37 degrees, different color for our y. Let me take a different color for y. And then where we see y is equal to 44. We can replace y with 44. X can be replaced by 37 degrees. Here is our x. And y can be replaced by 44 degrees. Now, let's substitute. That is substituting. Then we will remember, if it is sine squared or cos squared or tan squared, what it simply means, it means that sine all squared. Sine of what? Sine of x all squared. So what it means is sine, what is our x? Sine of 37 degrees all squared plus 2 cos. Remember, our y should be replaced by 44 degrees. Now, using your calculator, you'll get the value of sine 37 degrees. You can open bracket and close bracket, or open bracket, then you type in your sine 37, then close your bracket and square. So you'd realize that that sine squared of 37 or sine 37 all squared will give you 0.36 if I round off here. Plus then you type in 2 cos 44 degrees. Always make sure that your calculator is in the correct mode, which is degrees. Make sure it is not in radians or gradients. It should be in the correct mode, which is degrees. We are working with degrees here. So 2 cos 44 degrees will then give you 1.44 if you round it off. Finally, the answer 0.36 plus 1.44 will end up giving you 1.80. That will be the answer for 6.1. Now, moving on with this paper, let us look at our 6.2. If you look at 6.2 there, they are saying without using a calculator, determine the value of, let me maximize it, secant squared of 45 minus sine 60 degrees divided by tan 30. So that's where we are going to use your special angles. Remember the special angle triangles there. That's where we are going to use them. Let's write it down. Our 6.2, we want, let me just go down a bit. 6.2, we want to find the value of, let me write it here. 6.2, we want the value of secant squared of 45 degrees. Secant squared 45 degrees minus, just check my pen here, minus sine of 60 degrees, divided by tan 30 degrees. Now, allow me to draw those triangles, special angle triangles. Now, we will have the one of 60 and 30. If this is 60 here, we have in 30 there, 90 degrees. we must know that this side will be square root 3, 1, and 2. And then for 45, the triangle, if this is 45 here, 45 then 1, 1, square root 2. This is 90. So I hope this one of 45, let me redraw it so that we can clearly see our 45. Okay, let me just redraw this one of 45. Here is 45, 45, 90, then 1, 1. Then we have square root 2 here. Now, let's look at our first question, or the ratio then, is secant squared of 45. Go to the triangle of 45. Remember, secant is the reciprocal of cos. If cos is adjacent over hypotenuse, secant will be hypotenuse over adjacent. If you look at our triangle here, any 45 can be used. The hypotenuse here is square root 2, then the adjacent is 1. Whichever way you look at it, even if you use this 45 here, the adjacent or the hypotenuse is square root 2 and the adjacent is 1. Now let me replace secant square of 45 will be square root 2 over 1, and remember it is all squared, minus, now look at the triangle of 60, sine of 60. If I use 60, remember sine by definition is opposite all over hypotenuse. The opposite of 60 is square root 3, the hypotenuse is 2. So it will be square root 3 over 2. Then what will be tan 30? Remember, tan by definition is opposite all over adjacent. If I use 30, the opposite of 30 is 1. The adjacent is square root 3. So tan 30 is 1 over square root 3. Now, moving step by step, if you square root 2, you end up with 2. You square 1, it still becomes 1. Minus, remember we have square root 3 over 2. Change this division line to multiplication. And let's see what will happen there. If you change division to multiplication, that fraction below, 1 over square root 3, you have to reciprocate it, meaning the denominator of this fraction, we will make it our numerator, and numerator becomes the denominator. Now, moving step by step with this, what will we get there? We have 2 over 1. What is square root 3 times square root 3? Square root 3 times square root 3 will give me 3. And then 2 times 1 will give me 2. Now, 2 over 1 minus 3 over 2, it's just like 2 minus 1.5. If you subtract 1.5 from 2, you'll be left with half. So the answer will then be half for secant squared of 45 minus sine 60 over tan 30. We will end up getting half as our final answer. That is question 6.2. Now, looking at the next question there, allow me to go to the next question, which will now be question 6.3. Now, in question 6.3, moving step by step, we must first read the question. I will maximize so that we can see the question. Given cos theta, there you are given cos theta equals to 5 over 13, and sine theta is less than 0. With the aid of a diagram and without using a calculator, determine the value of sine theta 6.3.2, secant theta plus tan squared of theta plus 1. Let me start with our given information to answer this question. What is it that I'm given from this question? Let me write what is given. I'm going now to, because the given information will help me to get the correct diagram. Remember, my terminal arm can be in the first, second, third, and fourth quadrant. So we need to know which quadrant are we working in. Now let me write our 6.3 there. 6.3, we are given that cos theta equals to 5/13 and sine theta is less than 0. Looking at this question, look at your cos. Cos theta is that 5/13, positive 5 divided by positive 13. So the ratio is positive. And we are also told that sine theta is less than 0. Less than 0 means negative. So we want a quadrant where cos is positive and sine is negative. So it means you must know your cast diagram. In which quadrant would you find cos to be positive and sine to be negative? Remember, cosine is positive in the first and fourth quad. So we cannot take the first quad because in the first quad, sine is also positive. So the relevant quadrant here that we are working on is the fourth quadrant, because that's where cos is positive and sine is negative. There we are. We are in the fourth quadrant. Now, looking at our quadrant, remember what we are given there. We are given that cos theta is 5/13. Cosine by definition is adjacent over hypotenuse, meaning this is our angle theta. This will be the adjacent and this will be the hypotenuse. In terms of x, y, r, in terms of the Cartesian plane, the side that is missing here, it will be that y. Now we must complete. Remember, now we are answering the question 6.3.1. They want us to find the value of sine theta. So for us to find the value of sine theta, we must complete the diagram because sine is opposite all over hypotenuse. The opposite side is that y, it's unknown. So we must calculate it. So using Pythagoras, y squared equals to r squared minus x squared. Our r, which is the hypotenuse there, is 13 minus our adjacent there, which is 5. That will be our x in this case. 13 squared, which is 169 minus 5 squared, which is 25. 169 minus 25, it's 144. That's our y squared. Then what do? Introduce the square root both sides. Square cancel with the square root. Y equals to the square root of 144. Remember, it is 12. But let us not forget, as we move with the quadrant, remember, if we were in the first quad, for example, in the first quad, both x and y are positive. In the second quad, x is negative, y is positive. In the third quad, both x and y are negative. In the fourth quad, x is positive, y is negative. Are we together? Now, however, we don't have a problem with r, the hypotenuse. R is always positive. X and y are the ones that will change immediately when you move away from the first quad. Remember, x and y can change, can be either positive or negative. So we need to, as we are taking the square root of 144, we must write plus or minus. So y can either be positive 12 or minus 12. Then we must look at the quadrant. We are in which quad? We are working in which quadrant are we in? We are in the fourth quadrant. What are we saying about y in that quadrant? Y is negative in that quadrant, meaning y will then be between positive and negative. Y should then be negative 12, reason being because of the fourth quadrant. So you can just abbreviate in bracket fourth quad. You give the examiner the reason. We are not done with the question. Remember, they want the value of sine theta 6.3.1. Now that we have completed our diagram, we can see from our diagram our Sine, remember, by definition is opposite over the hypotenuse. Now we know our opposite is minus 12. We calculated it. The hypotenuse is 13. So therefore, sine theta will then equals to our opposite. Now it's minus 12 over 13. So that's how we will answer question 6.3.1. Now we also need to answer 6.3.2. Remember, we must also look at 6.3.2. In 6.3.2, there now, they want the value of secant theta. Now looking at the value of what? Secant theta plus tan squared of theta plus 1. So we are going to use our diagram there to find the value of that secant theta plus tan squared of theta plus 1. Now, let us calculate it together. 6.3.2. We want the value of secant theta plus tan squared of theta plus 1. Going back to our diagram now, 6.3.2. We want secant theta plus tan squared of theta plus 1. In our diagram, remember, secant by definition is hypotenuse over adjacent. It is the reciprocal of cos. And we are already given that cos is 5 over 13. Then it means our secant theta should be 13 over 5. Plus, remember, tan by definition is opposite all over adjacent. Going back to our diagram, the opposite is minus 12, the adjacent is 5. So it means we will say our tan there is minus 12 over 5, and it is all squared plus 1. Now, moving step by step, we have 13 over 5 plus, you square minus 12, you get 144. And when you square 5, you get 25 plus 1. Addition of fractions, our lowest common multiple between 525 and 1 will be 25. Then you can say 5 goes how many times into 25? 5 times. And that 5 times should multiply by 13. You end up with 65 plus 25 into 25 goes once. That once multiplied by 144, it's 144 plus 1 into 25 goes how many times? 25 times that 25 times that numerator, which is 1. 25 times this one up there, it will end up giving us what? 25 times 1, it is 25. Therefore, one can clearly see that if you add 65 plus 144 plus 25, you will end up getting 234 all over 25. So that will be the answer for question 6.3.2 under trigonometry. We still have to answer question 6.4, which is now another question. Allow me to end this one here. I'm going to prepare another clip now for 6.4 and 6.4, ending with 6.4.2. Let us just say for now we have answered starting from 6.1 and still 6.3.2. Then we will go to the next one, which is 6.4 and up until 6.4.2. Let's for now stop here.